Looks like we are live. Let's see if I can get chat up on my phone here. So I don't have a second monitor. So if I could do this, that'd be very helpful. Which I'm not sure I can. I can watch it on my phone. So I might just do that. Quality. Maybe not. I'll just come back and check chat every once in a while. I'm sure it's going to be pretty quiet for quite a while. Anyways, so as the title said, today I'm planning on working on this little robot here. Hope I'm in the right scene. Yep, perfect. So I decided to create this as kind of a unofficial capstone, I guess, of my engineering degree. So I figured kind of combined everything that I learned throughout engineering, everything I kind of tried to at least study in my last year where I focused on robotics. And so I figured you can do the reverse kinematics, inverse kinematics, forward kinematics, all the different kinematics with the robotic arm. Had a little bit, I'll do a bit of computational, not fluid dynamics, I guess, just finite element analysis, just to try to figure out the stresses in the components, to figure out, make sure none of those are going to break under load. We'll do a little bit of just basic mechatronics, controlling all the little servos, do a bunch of modeling and control all those servos, use the kinematics to define what goes where. And then the end goal for it is I made up a set of these, I guess basically dice, where I have numbers on the sides of them. Numbers, I got the right side up, 1 through 6. And the end goal is to use machine learning algorithm. I'm going to mount the GoPro webcam onto the final end grabber of it. And the idea is to create a machine learning program, control this with Arduino and then Python on my computer, and create a robotic arm that I can toss those dice onto a surface. It will recognize which dice is which and stack them or line them up in order. And then after I considered all that, of course, dog starts barking. Oh, roommate's here. Morning. So about that. So with that done, or with that, I figured with this robotic arm, I'm going to have the GoPro mounted to it. I figured I could also just use it as my webcam mount instead. And so instead of this defined center mount at the top of my monitor here, I was figuring with the robotic arm, I could then say move it and have it like placed as a document camera and use that. So if I ever want to draw something, I'm going to be drawing a bit here in a second, and unfortunately won't really be shown on the screen, but I can use it as a document camera, or you can also have it stretched out and just watching the 3D printer, and figure that'd be kind of fun for overall live streaming experience, just to have that 3D printer view. And I guess I could just do it with a series of cameras, but I just figured it'd be so much cooler just to have the one and just have the whole robotic arm move it within all the different spots and locations I want it to be at. Appears my mic might be peaking a little bit, So I'm going to lower that down just a little bit so we're not getting close to the red zone. All right, with that, I've got most of the robotic arm done. I have this bottom section, bottom base plate. I have to order a weight for this. I'm going to just get a machine shop nearby to cut me a nice 1-inch plate of steel, and we'll stick that in the bottom there to balance it all out. And then I have 6 of the 7 servos in position with all their various screw holes and bolt cut throughs and nut cut throughs and everything in position, so this should all be ready to go. And now I'm just working on finishing up this last little end effector, which is going to be where the grabber sits and this final servo sits and where the actual GoPro webcam sits. Guess as far as this robot goes, nothing too crazy interesting about it. For all the pivot joints, I tried to make the joint so it actually support the weight of the rotation and support the weight of the robot, so it's not all just on the little pivot of the actual servo. And so on the base plate here, it's all fixed. I forget, I guess you're the last fixed one. I don't really want to move it because it's all got a break, but oh no, this one's fixed as well. No? Who's fixed? Are you fixed? You're not fixed. Are you fixed? You're fixed. So this big base plate on the bottom, it sits on the secondary plate that the servo is attached to, and then this will rotate and the weight will press onto the base plate as opposed to being pressed onto the actual servo. So I did the same with these 2 rotation joints here. And so there's actually 3 components. I'll make this transparent so you can kind of see. So the end of the link goes, and then it goes to a circular extrude. And then I have this kind of coupler link, I think I called it. Or I just call it a swivel link. But basically, this swivel link will attach to the second joint. And so I'll make this transparent as well. So you can see there's the propeller of the servo. It is flush or flush enough with this front face. And then the secondary joint will ride along that front face attached to that servo propeller. And this final coupler will then hold these 2 joints together, because while there is in these servos, there's a little screw that attaches the actual propeller to the servo, but I didn't want a whole lot of force being applied to just this one little screw attached to there. And so with this, any major forces should be applied to the backside of the swivel here and reduce the actual weight on the servo to help keep it from breaking. And so I did that with both of the swivel joints. Both have the same connection. I just have little screws to hold it together, and then a very tight clearance there, which should work out in real life. I'm going to be really sad if it doesn't, because it'll be kind of a pain to sand this down so it does clear, but we should be fine. Alright, I guess I'll leave chat on here. No one in the chat still. No one alive? Not surprising. Alright, I'll get to drawing. I find it incredibly easy to kind of lose scale of things in Solidworks. And so I'm going to draw out the kind of the basic idea of what I want to have for this robotic arm. And then with the robotic grappler at the end, the clamp. Once I do that, I'll I'll quickly show it on camera. I actually might be able to balance the camera on my GoPro or on my water bottle here. Just give me a second on that. I might be able. Let's see if this will work. Will you stay? You will not stay. Can I wedge it like that? No. Yeah, I don't see that working unless I add some glue to it, which I'd rather not. So instead, I'll pivot this down as much as it can go. How does that look? Okay, you can see reasonably well. Hopefully my audio's in track with my mouth. That'll be awkward if we're behind, but oh well. So with that, let's see, I got the drum. Naturally, I got one of the servos. Doesn't fall off. Got these servos. I think I bought them off of AliExpress. I believe so, yeah. I don't think I got these off of Amazon. Yeah, I have a bunch of 20 kilogram servos and then one 25 kilogram servo for the servo, the pivot servo at the base, because that's going to be where most of the torque is required. As you go along the arm, there's less torque required. Naturally, as there's less force. Anyways, let's see which of these circles would work the best, which of the propellers. And I'm guessing this one right here is probably what I'm going to want to use. It's got the smallest profile on it, which is good because I don't think we want anything too crazy wide. There is a super big one, and then there's also a little cross one, and there's another smaller propeller, which I guess went into a different bag, but I'll stick with the circle now because we'll be attaching the servo to the, it's going to look like half a gear basically, because we're going to have the servo attached to one arm, and then it's going to gear over to the second arm to help pivot both arms at the same time. It's a very common robotic arm or robotic grabber mechanism, so nothing too out of the ordinary there. Chair caught on something? Nope. All right. Let's see, hopefully my audio is still good. We're still at decent volumes. Perfect. Let's see, you got this circle here. And actually, what is the width of this again? Width of you got a diameter of 64. Cool. Back to correct screen, nice. Break out the old caliper to measure. Suppose I could use a ruler, but I don't know. I just have this caliper here. It's very handy. 64, close enough. So the coupler to it, let's line this up right in the middle of the page. It's going to be yay wide. Or so, close enough. It doesn't need to be perfect. We'll make it perfect once we get into the actual SolidWorks CAD software. I think I want to rotate this a little bit. Hopefully that's not too loud. I think we're good. No chat, no problem. It's all right. Just gonna do a basic top-down view. That'll be the most important. I kind of have an idea of what the bottom view I want, so top should be the focus. So we'll have the servo in the middle. We're going to want it on the top so I can have the bottom of the grabber flush with the table. I want to be able to have it nice and flat so I can grab these blocks like this or like that, I guess, as opposed to having to go like that all the time. I think I might grab it like that anyway, but it'll be nice to have the option to go in just from sideways and perfectly flat. So servo was it like that ish? How much room do we need for the actual pivot? It's not going to be much. From here, it's only 5 mil wide, so we can reasonably make that. I guess we'll make that 15 mil. So we'll go to 15 mil. We'll be right around there-ish. We'll have servo switch back. The servo there. Draw this out. Very scuffed, but it works. Servo there, might as well have it nice and flush up against where we're going to cut off. Servo, you are about yay wide, and the actual pivot is going to be along that line. Sketch this back out. Top profile of the servo. I want to be halfway in the middle. So middle pivot servo will be right around there. Will that work? Let's see. That's going to need to rotate. So no, we're going to need to. Let's stretch this up backwards. Because we'll need room for the actual gears on the arms to rotate back. Otherwise, they will just be locking into place. And I guess let me do a quick search so I can kind of show you what I'm looking for. Robotic grabber. And back on the right screen. Yep. Cool. Images. Why are none of these what I want? I guess this is kind of as close as we're going to get. So the idea is the same basic idea as this. We'll have two circles. The servo attaches to one of those circles. Those circles interface with a set of gears. We'll then have a 4-bar linkage of equal lengths on either side. So I can close and open nice and evenly. We want to have a nice flat face in the middle regardless of how wide the jaw is. And then we'll have just the jaws stick out, and that'll be the actual clamping mechanism. I think for this here, it has like the one arm on the top, and then at the bottom it has arms on either side. I think I'm gonna do the opposite, where I have just one arm for both of these, and then I'll have the jaw being the clamp that holds those two pieces together. Would it make sense? More sense to do it differently? Don't think so. No, that way the jaw can be nice and flush to the ground. You won't have this bottom arm to worry about. So yeah, I do want that bottom jaw to be like that. And back to cam. Good. All right. Back to drawing. That's kind of the basic idea of what I'm going for. So it's not a novel design at all, but it will be novel to me because I will be making it all by hand. So let's see. Drop the circle. Nice. line the circle up, line the circle up. It will be about 8 wide. That will be the minimum size of the gear interface. Which looks like it'll work pretty well. Let's see. I want this. This was 64 wide. 64 wide. Let's mark a line in the center of 32. Apologies if you hear the motorcycles outside. As I said in my last video, I do live right on the side of a highway, so there is a bit of road noise going on occasionally. So just drew a line down the center, and that tells me that I am going to need, I'm going to want to shift this whole thing over. I guess I don't necessarily have to. I could just have the circle overlapping the gear interface, but I don't like the idea of that. Seems much better to have that circle and then have the gear be a little bit wider than the circle. It just looks cleaner. I'm not going to run into interference if like the gears get wonked over and then it's bumping into the circle. So gear interface will want to be at that middle face there. Circle, there's circle. Of course, now I have an ambulance. Fantastic, fantastic. Feels good to be on a highway. Let's see. Circle here. Oh, never mind. That was a fire truck, not an ambulance. Okay. So to mount the circle there, I can make the final gear. Let's see, we're going to be making gear in Solidworks. So let me first check what sort of sizes of gears we have. Gears. Just want a spur gear. I thought I might have to make this spur gear myself. Just going to upload into it. Of course it is. That's not what I want. Cancel. Cancel you. Get out of here. New part. But you can just edit these. Why do you do this to me? I don't want to manually edit it. Exit. Features. Delete. Of course not. Why do you have to be difficult? SolidWorks. Sketch. Okay. Try that again. New part. Edit you. I want to bring spur gear in. No, I don't want either of those. Don't save. Part 2. I want to bring spur gear in. Now, why can't I select other? Just edit the sketch. That's just a simple round. Features. You are in read only. Okay. Save as new. You are going to be in. Does that shift? Okay, it does shift it still. Nice. You are going to be saved in. New version 1. gear arm. Okay. Can I edit you? Edit the feature, no. Okay. I don't know why you don't work. Go back. Base revolve. Tooth cut. Teeth cuts. Can I edit this manually? You're in millimeters. Of course, this is all controlled by stuff. Why are you not giving me a nice thing? Solidworks. Okay. Break here. Configure. Great part. Okay. Don't. All right. Now we're good. I think. Just delete you. Yeah. Get out of here. Okay. Configure what? I don't know how you haven't been saved for 20 minutes. It's only been open for like 5. You're crazy, Solidworks. Don't save. All right. Try this again. Bring out the spirit gear. You aren't working still. Alright. Boom. Great part. Boom. Okay. We have finally done it. Face width, now to remember what all of these things change. What a high module, yeah. Let's see. 2.5, another teeth 10. Like 14 pressure angle face width. Can I evaluate this? Okay. How wide are you? You are going to be 40 mil across. So it'll be 20 halfway. We have a 64 mil gap. So it'll be 80 total. These gears are just going to interface in the middle, so I really only have to have them halfway. 20 either side. Should be fine, but I think I want to go a little smaller. So maybe decrease the module. If we go to 2, how wide are you now? Two. 32 mil across. I'll be exactly halfway, except the bit of the overlap, which is fine. That's going to be fun to calculate. Style. That's fine. Number of teeth should be fine. This always looks goofy, but so I can see how it actually works in real life. Wait, was this 64 all the way across? No. This one measured to there. That's a radius. That dot. 2, no. Okay, 32 across. So this thing is going to be pretty small, but those teeth should be fine in the grand scheme of things. How does it look on camera? Can you even see that? I actually could see me looking like a goober holding my calipers up to the monitor. All right. So we're at 32 across. These are going to intersect halfway in between. What's the difference between these two radius? You're 16. You are 11.5. 16 minus 11.5. 4.5 mil. That's going to overlap at 2.25. All things equal, which they should be, yeah. So it'll be 11.5 plus 2.25. I can't do math in my head anymore. It's really bad. You get into a final exam and you're just calculating 2 plus 2 on your calculator, but that's just the way it is. But all right, so our circle, we'll be looking for a radius of 13.75. And that will be to the middle line. 13.5, 13.74. That will be plenty good. Move this back a bit. Let's see. Center of the circle there. No overlap. Very nice. Let's get a couple other marks just to get an idea for the circle better. Circle goes to there. Except that's not the final teeth destination. We will need 16 wide, was it? 16, yep. 16 mil wide. So that is as close as we will want to get. So make that the center of our circle. Actually, if I change my camera, no, that's not what I want. Change you to narrow. See a little bit better, a little bit closer. So yeah, outline the circle. It gets us there. I think I'm only going to draw 1/2 of this because I'm just going to mirror the same shape on either side. So we really only need the 1/2. 16 to there and 16 to there. Line those up. And I'll add the full circle just for the sake of completion, kind of just as a construction mark to get an idea of where the teeth will be going. Terrible circle, but I will pretty it up once I actually get into SolidWorks and can draw a perfect circle. So that'll be that. Overlaps in the middle. Other gear will sit something like that. Perfect, perfect. Do I draw this open or closed? So we draw it closed. Which, because first off, draw the second pivot point. This first pivot, second pivot, right around there. And I guess we're going to want this wide enough. Going to want this wide enough that hopefully it won't be seen by the GoPro. Try and remember if I have, I think this is just a 90-degree servo. Don't quite remember. So, as far as the Solidworks goes, that's not what I want. Oh, I can't do anything until this is done. What else do I want to change on there? How am I going to attach this? Those will attach to there. Dig that up. Okay. Doable. We're going to want, I guess we'll just use a nice big bolt that I have. You are 4.09, so we'll want a shaft diameter. We'll go 5. I guess I can edit that later. Number of teeth, pressure angle. If I go 14, what does that get? No, let's go 20. Module 2, that size is good. Edit anything else later. I think I'm happy with that. You configured. Come on, Solidworks. You can load. I believe in you. You've got this. Maybe. Maybe not. Okay. Solidworks is lagging out, but we'll continue in the meantime. So got that. You're still loading. Back to camera. Those pivots to there. And then the jaw. Again. Line it up. I have my ruler. No, a ruler's in my room. I don't need a ruler. You nice line down the middle. Jaw clamping. It's right around there. Should be good. Say failed. You kidding me? Did you work? Are you good? This is the gear. I think this is the gear we want. Radius 16. That's 5. All right. Everything has saved. Hopefully that didn't make a bunch of noise. All right. No, this one. Sorry if I'm jumping through scenes and making it rather confusing. As far as width-wise, these like 3/4 of an inch. 1 inch. 1 inch wide. We'll make this. I'll go 2 inches. 2 inches, yeah, let's go 2. 2. Basically from here down to here, nice. Almost even 2 inches, that'll be 50 mil, but close enough. And how do we attach this? So if we have these, arms will go out roughly like that. Roughly like that. We pivot those back. Just about touching. That'll be nice out here. That'll be good. I'll keep that there. That'll be a pivot point there, pivot point there. And this arm looks something like this. Nice smooth lines. It's gonna be a little fun to do in Solidworks, but that's okay. Be happy with that. So here, we'll have the one arm going. Here, the second arm going. Which will be connected directly to the gear. Nozzle. This goes back. That peels off. How did these look? Those look much different, but they're closed. This is basically going to be straight, or that piece is going to be straight like this. Well, this piece is going to be straight like that, because it's only going to it's going to rotate 90 degrees. So 90 from here, well, will be a little less than 90, because 90 would be completely closed, well, over closed. And so it'll rotate to being straight to clamp those two together. Or mine doesn't rotate to being straight, so there has to be a bit of an inset on it to keep it closed. And with that, when that cycles around, it's going to be out to about here. Servo here, GoPro there. Might be a little bit in the corner of it. Hopefully not. Actually, I guess this will be going to be very tight in. That might not even work. Let's see. Let's go draw this in Solidworks, get an idea. No new chat. That is fine. Software, no views, no comments. As I expected. Alright, top plane. How do I want to do this? I guess we can just do 2 lines. That'll be our interface. These lines are going to be like so. You are approximately 36 long. We'll make it 35 because that's a nice number. That's not what we want. Get out of here. Sit out of here. Just not going to delete? What's going on? Interesting. So now, edit scenes, and the delete doesn't work. Now it does. That is very unfortunate. I still have to swap those. I'll do that next time. Do 14. So we'll try to do this based on the quick drawing. You will have a gap of 35. I'll make a nice even square. You will be in line with you. You will be vertical, and both of yous will be 13.25, 13.75, 13.75 away. All right. And we'll draw second line. You will be 35. That will act. Should act like a 4-bar linkage. Yeah. A 4-bar linkage. Now off of that. Let's see. Let's set these. Okay, I'm gonna change that. To settings, hotkeys. Scene 1 would be you, you, and you. Apply. Okay. And now I can't press down on my I just learned to use that button. I guess so. Hotkeys again. Numeral. Any better keys to replace this with? Not really. Num 1, Num 2, Num 3 like I had. So that'll cycle nicely. And we'll just use a different delete button. Okay. Back to the broadcast. So our 4-bar linkage. Now we want to create the actual thing. In reality, that's going to be just a little bit past this bar. Just going to be 50 long. No. Coincident. Nope. Delete. Use other delete. 50 long. Very basic how that looks. You should remain vertical. Yeah, okay. Initially, you are coincident. And to keep distances, will this work? Should work, yeah. You will stay the same. That arm will rotate, but that arm will not. Okay. Now, what is holding you in place? Why do you not want to move? Can I? Construction line. Slide you across. You and you. You are going to be negative. That'll drive it interesting. Delete this one. Exit. Now that will rotate. You can go up and down, so why don't you? This is supposed to make this process easy. Why is it not making it easy? You again. Coincident. Not coincident. You. Let's keep that angle the same. No. Okay. So we go all the way back. Is going to want to bump once we reach a little bit past the 180. It will connect as I worried it would. Guess that's why you go straight to 90. Can we go straight? Guess we can, but that's also why you have those offset. Right. Offset those, stick those in the middle. Pivots to there, the layers go straight. Okay. Action key working, cool. So I'll leave that up so I can see chat, just on the off chance someone joins me and gets rid of this old loneliness of sitting in this stream all by myself, working on this robot all by myself in the silence, because I'm worried about getting copyright strikes, so I don't have any music to play. I think I'll try to get some music for the next stream, because it's definitely going to be a little boring and a little long. Well, I guess it'll just lead to me meandering with my thoughts. Just saying a lot of stupid stuff as I just keep talking and talking and talking and talking and talking. But all right, so that's offset. I'll have you nice in the middle there. Yeah, okay. Nice in the middle, stick you on the line. So that looks better. Hands blocking it, oh well. Then this bar will go straight to where it attaches. This bar will go straight to where it attaches. I do want to offset those a little bit, okay. Why do I think I'll need to make those? Shouldn't need to go too wide. Then wide, I can just do crazy. Let's do like a 30% infill to make them super stiff, but still keeping them skinny. Does it matter if that's very close to the center line? Not really. Torque is going to be this about the same, yeah. That's fine as is. Don't want those to be super close when closed. I think that'll look a little bit cooler and have them nice and tight. Just about there. Stretch that across up to there. And we'll move the grabber in so it's not quite as far out. To here. Guess we'll just use the scale on here. 100 to 150. Yay long. This curve up. This curve up. And cycle that around nice and smoothly. That's going to be a big waste of print. So let's just cycle it like that. Cycle that back up, save on some material. Hound's big face like that. It's gonna make it really obvious if those aren't centered. Do I make a little pad in the middle to offset to that? So make, I'll show on the screen. How do I do this? Oh, sorry about that. I got a little end of the grabber here. And so I can make a little pad that goes on the middle of it, and I'll just have like a pivot point right around there. And so once those press together, it will help adjust for any sort of angle difference between this line and perfectly parallel. But will that make it a little less stable to grab things? I don't think so. Should be fine if those close together. If it's offset, those will stick out. Which you can see maybe squeezing the thing out. So do I just want to make a super tight grabber? Or do I make a grabber where I could attach that if I wanted to? Might be the play. Given an adjustable jaw, so I can switch it out depending on what I want to grab. I think that's the way to go. I think that's the way. That'll future-proof it a little bit, so I can much more easily adjust it to whatever I need. I don't need to print off like a whole brand new jaw system. I can just do the one. So let's see. They straight like this. Yeah, it's gonna take. Should be nowhere near, even if I do a slight angle on them. Should be fine. I'll check the Solidworks just to make sure. Okay, so I have. No, I don't want that. Don't want that at all. Just like that. Those like that. You will do like 4 mil. That's kind of the jaw shape. So they'll start at a bit of an angle. Yeah, go all the way back if need be. And that'll give me a bit of space to adjust the jaw. And so adjust the jaw, make 2 halves, and then you can just slot something in the middle and bolt it. With a little bolt on the bottom. I guess it bolt through, have the head countersunk in a bit so it's flush. Should be good. Yeah. Should be fine. All right. Drawing number 17 million. I'm glad I tried to draw this out before I stepped into Solidworks. It's much easier to just erase a drawing than to redo an entire assembly. Or redo a big Solidworks piece. See, at their most closed. Do this wide. Give a bit of room. Act like there is an attachment on it, but in reality there isn't. Then I want to move that in a bit. Because there's no sense having it be a little more stable. Have much better jaw profile. If that arm is back. That to you. Make sure on the right camera. Switch here. You aren't parallel. That looks terrible. Just you. That sounded like a loud truck. Hopefully that wasn't picked up. Go there. I guess we'll do the pivot piece. Make it flat. Actually, this way. You can also take the jaw off in case the jaw gets in the way of the GoPro. that. I guess it doesn't make... Do you sweep you up and around you. Back around to there. It's big enough for the bolts. Big enough for the correct nut. This is going to need to be bigger. Stretch you a little bit. Extend you out a bit more. Turn it nice and flat. I really want the pivot to be in the middle of that line. So I can extend the line a bit that way. We want middle of the nut, right around there. U for my OCD, make sure that's even-ish. So it goes back around to there, to there, to there. All right. These are going to be inside, this will be two halves on the outside. So they'll be completely different. And then if I want to make a jaw, do something like that. Sticks out. Connects like that, and I just do like a little block on either side. If I wanted to limit its rotation, those would bump into the flat surface, but the jaw would have a bit of wiggle room to help accommodate screw-ups. I think that's good. I think that looks relatively fine. That cycles around. Jaw like that, it's going to bump into that bar as soon as it hits, or before it hits 90 degrees. So that just means we'll limit the size of it. This goes, we can hit the 90 degrees, and then pivot it back. Be fine. Do we stretch that out farther so we can accomplish larger or smaller jaws? Or do we just make a jaw that pivots around that? Always out be on the front of here. Make it wide, little gash in the middle so it passes through those. And so that will leave us pivot room until that touches minimum angle. I think should be fine. Don't think we're picking up anything crazy. Worst case scenario, I reprint those to accomplish or to accommodate the much larger jaw design. That's good. Easy enough to adjust that in Solidworks afterwards if need be. Right. where this front face goes. I think we'll just do like a nice half circle maybe. Be a nice clean flat platform for it to pivot around. We'll just go up to there, those attached there. There, works that. I'll have that attached there. I'll stick up a fair bit, but it'll be fine. Okay. That's good. Let's maybe draw this side profile now. So you start out 64 mil circle. Gets us to there. Circle extends. For actual grabber, we're going to want to make this. That'll be the flush bottom piece. Let's probably make that 10 mil thick or so. And that'll be this kind of flat circle that everything mounts on. Then we'll go up. Probably make the gears 5 mil thick. I think 5 mil should be fine. 10 mil off for bolts, yeah. Make them 5 mil thick. That should be strong enough. Then sandwich on top, I think we'll maybe make something on this gear to help hold it in place better. Yeah, because how we're gonna attach it, I guess. Will a bolt just slowly untighten? Might. Want to rivet it? Not really. How else can I attach a circle? Attach a spinning circle. Guess I can inset the gear, make a piece that doesn't spin but locks it in place, and have the bolt up against that spinning piece, have that inset, and have the gear a little bit taller. For which one? I just have the bolts inset, so it might just be fine. I guess it's might be fine. But I don't want to find out if it's not fine. So I'll make it with the idea that it's not fine in mind. All right. Let's draw this out again. We have 5 mil wide. drawing kit here. No. We'll have 10 mil deep base. That goes out straight. 10 mils above it. And I'd have a... There actually was people here, I'd have a real hard time thinking and interacting with chat at the same time. That would be very near impossible. Wouldn't get anything done, just be talking to chat. Like a video game where I can just shut the mind off almost and just kind of go on autopilot. Gotta focus the entire time. Guess maybe when I was doing like a Solidworks build or something, it'd be a little better. Still kind of rough. Okay, it's got like that. Servo here. Pivot that down. Put the GoPro here. Have that down set so I can press the GoPro up against something to keep it a consistent spot. So it's super easy for the machine learning algorithm, and it doesn't have to recalibrate to a different location every time. I want this 10 mil wide. Get the robot. Maybe a 5 mil wide flat circle. What about 10 mil wide? 5 mil seems a little thin. 10 mil wide. And that basically goes all the way to the bottom. We'll then add, ooh, it'd be nice to have the GoPro dimensions, excuse me, camera. Let's put you on use here, don't feel sick. You will have to offset it. The back of the circle to the back of the camera. I'm looking at 4.3 millimeters. Good camera, cool. Back of the circle. And sorry, let me measure again. Can I not measure with you attached, please? Okay. Circle is 15.1 across. 15 point, oh, I should have wrote that down. 15.1, we're looking at 7.55, 15.1 divided by 2, yeah, 7.55. Still do a little bit of math. So down, yeah, it was right around there actually. Position of the servo at. Servo, how thick do you want our gears? 10 mil gear. 10 mil will be real chonky. I can make the arms skinnier. That should be fine. 10 mil gear. That is 32 across. Center across gets us to there. Drag that down. Tracking gear indeed. This with the circle on it. This flush. Set up to there. Do I put the GoPro in front of that then? I think that makes a ton of sense. Means I might want to back that out a little bit. Yeah, Sophie. Let's get, oh, I keep bumping into that, sorry. Let's make a big noise in here. It does make a bit of a noise. Sorry if that's super obnoxious. You there, gear to there. Second tip of gear to there. 10 mil tall. So that's the gear. Center the gear right around there. Servo up to there. The servo width is only about there. We're going to print this. That's from the bottom up. That's from the bottom up. We'll do a support from the bottom up. That'll work fine. Gears there. Second pivot. Our second link will be right around there. Make it half the height. And that means print from this side out. Attached to there, that goes to there. We want that to be attached as well. GoPro right up against the servo. Rather not. Let's see. Where the servo goes. You'll want. We're going to attach this. Yeah, I guess. That to there. Don't really need that screw. We should be fine without it. Yeah. Screw the circle into place on the gear. Set the servo in place. Hold the servo in place with screws on top. Servo can't move. Don't need that bottom bit. All right. So I'll do a flat extension from the back. This was the top side of the servo. Close enough to it. Top side of servo, put a bolt on there. Going around, wrapping around it. Do the front to 2 spikes going up. Those out. Full overlap. Those won't be centered either. I'm gonna make bracket as one. Stick it on the bottom. Little bar in the middle, but that'd be fine. That down to there instead. Off-centered. Let's look at that in the middle. Nice curves, don't need fill or supports. That goes up to there, that goes up to there. Be doable. Sort out to there. I can't have supports going from the bottom plate, so I'll run into those connections. So everything we do will have to come off of this back side. So I'll have to come off of this face here and extrude out, so we're not in the way of these rotating arms as they go around. So if we go off the back of the servo sitting. Why is the servo again? Servo sitting in place. Right. Something like that. Down to there. Rest there. Flush. Bingo. Bingo. Those arms stick out to there. Servo screws into those. Hold me straight out. Unless I do a big. An even half circle to the middle. I don't want to be to the middle. Do I print? Could make a connection off of there. Curve it up. Yeah. Okay. So I do something like this. God dang it. Curve that up to there. Put circle for the GoPro. Do I just have it up against the servo? Servo's not moving. Nice solid face for it to go up against. Will it rub and damage the GoPro? Don't think so. Maybe stick like some felt on there. Maybe just like stick a piece of duct tape across, but on the back of the GoPro, it's all hardened in glass. It should be fine. So yeah, looking at that, let me remeasure the GoPro because I have a memory of a goldfish. Zeroed. Roughly 4.4 for the back of it to the front face. Leaning forward at all. I'll just try to keep it flush. That to there, 4.4. To our 15 mil pivot point. And you might as well have this as low down as possible. And there. Circle. That sweeps that way. And sweep that up that way. A circle there. That looks dumb. Smooth that out. And then the GoPro attaches like so. Let's turn you off. Center the pivot to there. We're looking at 8 1/4. 8 1/4 from there. Back of the GoPro bumps up against the servo. Hold it in place. Boom. Boom. Pivots. And use the same skier clamp. That attaches there, that attaches to there. Print out from that back, that's supported, that's supported. Should be supported enough, that'll all be supported. That'll link up to there. That connects to there. It's going to be a very fun shape to make. That touch there, that's clamped there, those screw into there. As far as the gear goes, outer circles yay wide. So do a nice small inner circle. Can I use these? the top. Yeah. Bolt on the top. Do I have log one? I do. Bolt on the top. That's countersunk in. Sunk in. Then actual bolt rests on a separate thing that goes straight through, which the nut then sits down there. Printing from there. I guess I'll put the slot in from the bottom. Then front face ends like that. So I can pivot arm from there. GoPro there, servo there. GoPro can see everything. Pivot arms don't get caught on anything. Then I can pivot back. I can adjust the grabber in the arm. Should be good enough to go. All right. Let's see if I can quickly show it off. So we're looking to make something looks like that, if you can kind of understand it from the drawings. So top piece I already kind of explained, fairly simple 4-bar linkage that connects the gears that drive it. This will be mirrored on either side. Then we have a little adjustable jaw in the front, so we can adjust it to whatever I need to grab with it. Bottom, this will be the flat pivot face that goes up against the first servo. Then there'll be an arm that stretches out, which this servo is bolted into. So there'll be some bolts right around there, which will hold the servo in place. This bottom gear is then nice and thick, so I can do little countersunk, separate assembly kind of bearing almost. So that will bear the force of this, and I'll square out the bottom of it so it locks into this bottom base and doesn't actually rotate at all, so that the bolt doesn't slowly loosen with time. And then I have the two arms going out. This center arm will be mounted kind of right in the middle here, so that doesn't interfere with those two swinging arms. And that will go up to a little mount that I will attach the GoPro to. It'll be the same pivot mount as it was in that webcam mount I showed in the previous video. Then I'll have the GoPro mounted on there so I can see out front and look at everything without being blocked by either the servo, and with it being so far forward, I should be able to swing these arms back. This is so weird to do mirrored. Swing this back so it's like right around here, then the GoPro won't see anything and I'll have a nice clear view if I want to use it as a webcam in the future. So with that, that should be the basic design done. Let me adjust the camera real quick. Hopefully, oh, that looks better. I think I'll adjust this back to linear mode, slightly bigger camera. And then with that, I think I'm going to take a short break here. Starting to get a little peckish. So in the meantime, I think I'm just going to quickly see. Just right on the chat. Yeah, this was right in the chat, yeah. Give me a second. I'm going to put on some ski videos that I recorded Probably last. This will do some from last year. This might actually be 2020. Yeah, 2021. This is skiing up at Silver Star. Can't guarantee anything will be very good in them. I have just a ton of files saved onto an external hard drive. I'm just going to play one.
Anything to say for the vid, Carmen?
Mute them in case I say anything too weird in them. I don't think anything too crazy should happen in the videos. We should be fine. And I'm gonna take a quick snack break, to stretch my legs, and then I'll be back in, I'll say 15 minutes. So I'll be back at 11:20. Snack break. Back at 11:20. Alright. Working in cat. Enjoy the ski videos. Oh, anytime. Exclamation point. Snack break. Back at 11:20 to start working at cat. Enjoy the ski videos in the meantime. Boop. Sending. It is in chat. Switch to you, so you're just looking at the screen. And play. Okay. Go to mute. I'll be back in 15. Hello, I'm back. Hope you enjoyed that little interlude there. Is the camera on? What's going on here? Webcam, are you working? Hello? Am I a ghost? What's going on? Alright, I might need to restart something. Oh. Now we're just down. Oh. Oh boy. Oh no. What happened? Why am I... What is actually going on? This is mental. You are all loading. Computer's just straight up dying. Alright. It's looking a little better. Now if I can get my camera to work again, we'll be good to go. Alright, I adjusted it to narrow. What's wrong with it? Is it like overheated or something? I think it might have. Okay. You're just AMD Crash Defender has detected an issue with your display driver. What happened? I just got back. Why are we completely breaking? Okay. Gonna run without a webcam for a little bit here. I think it needs to cool down or something. It's not happy. I'd rather not end the stream if I can avoid it, so we're just going unplug that for a bit. We'll rock this webcam free view for a while. And with any luck, we can grab that again in a bit. Or actually, let's just try it. Restarted it. Start the camera back on. Plug it back in. Start the camera software again. Camera is still showing the old view. Cam software will run. Alright, looks like I'm gonna have to figure that out some other time. So, fortunately, no camera. Maybe I'll try that again at the end of the stream, but for now, we will just be rocking camera free. Okay. Bit awkward that look at the drive, like 100 or so videos in that folder, and the one video I picked is the one video where I duck a line and get stuck in the hole. Of course. Don't tell the lifties that. You saw nothing. Alright. Back into SolidWorks. Is anything gonna load? Not gonna lie, I think I might need to restart my computer because I don't think my desktop is supposed to look like this. This is I think we're having a bit of an issue here, so give me a second. I'll be back online in probably 5 minutes or so. I'm just gonna have to restart real quick if I can. I think it's Solidworks that I need to save first. Oh no. Oh no, no, no. Alright. Go to you. Can I end this from here? I don't know if I can. Can I end it from OBS? Is OBS working? SolidWorks working. SolidWorks is not working. Is my background still just mental? SolidWorks is just not loving it. Anything risky saved? I think we're good. Let's see, spur gear. 14 teeth. 2 module. 20% pitch angle. 5 diameter middle. Alright, I'll make that again. Okay. Well, thank you for watching this first stream.